Students, hi, this is Mr. Bob. In this video, we're going to talk about motion equations and also the DGUESS method of problem solving. Before watching this video, you should, one, have set up some sort of focus notes, either on paper, or you can use the digital template that's located at the URL indicated below. It also might be a good idea to have a colored pencil or highlighter ready. That's up to you. The essential question we're going to talk about in this video is, what are the motion equations and how can I approach complex problems in a way that helps me solve them? Just a couple of recommendations about what you should do about while watching this video, or how to take notes while watching this video. I would recommend you avoid mindless copying. If you find yourself drifting off, just do something else for a little while, or just stand up, but basically avoid just robotically copying. Do not copy everything you see on every slide. Some of the slides have information that really might not be necessary to copy, and it's more just background. And please feel free to abbreviate as you see fit. If I give you a sample problem, pause the video after I've presented the problem. Make your brain struggle for at least a few minutes to try and get as far as you can on the problem. And then you can unpause the video to kind of see how your thinking compares to the way I solved it. And if you're still confused at any point in time by the end of the video, then put a question mark at that spot in your notes, or write down POC, point of confusion, and make sure you make a note to follow up with a classmate or with me as necessary to kind of help you understand it. 2 learning targets for today. I can state the conditions of when the motion equations can be used, and I can apply the DGUESS method and motion equations to analyze complex situations. Quick question for you. What do you call it when someone is singing in motion? Walkapella. You knew I had to throw in some humor somewhere in this video. All right, here we go. Let's start talking about it. There's a big word there, kinematics. That really is just a big word that just means the study of how objects move. I do want to take a moment to just recognize how important this is, because if we know a little bit about information about an object's current motion or past motion, its position, its velocity, its acceleration, some combination of that, then we can pretty accurately predict things about its future motion. And I just want to emphasize that humanity over the centuries has built upon this knowledge, this idea of these motion equations and kinematics, to do some really amazing things. We're able to fly airplanes safely all around the world doing that. We're able to send astronauts into space, spacecraft to foreign planets, and we're able to predict things like eclipses and all sorts of motions of planets and stars. This slide right here has a bunch of abbreviations, and I just want to walk through them. The equation sheet, these are AP abbreviations, and the equation sheet for AP Physics does indicate or show you what some of these abbreviations are, but this is a little more detailed. And I just want to kind of walk you through and make sure you understand how kind of to think about this. So remember, the X stands for position. We've talked about that in class. Now you see a subscript here, a little O. I want you to think of that as initial or original position, or position at time 0. Notice underneath there, the second row is final position, X without a subscript. Okay. Delta X, remember that triangle stands for change in. So this would be a change in position, otherwise known as a displacement. The V we know is velocity, but what about the X and the O that are both subscripts? Well, again, the X in this case, it just gives you a sense of what direction we're talking about. Whatever we've defined as the X direction, that's the direction of velocity we're talking about. Doesn't mean much to us now, but later on, when we start looking at motion in 2 dimensions, we might have lowercase v with a subscript y, and we'll have to distinguish that from the X, because you'll have an object that's moving both in the X direction and in the Y direction simultaneously. The O we already talked about, that stands for initial or original or velocity at time 0. V with a subscript X, that's final velocity. T is change in time, okay? And sometimes it's written as delta t, as you can see there on the right. And then finally, acceleration with subscript X is simply acceleration. And again, the X just denotes the direction. And in the future, you might see A with a subscript Y, and that would be the acceleration in what we've defined as the Y direction. Okay, the equation I'm going to show you here, you're going to use a lot. Now, again, you do not need to memorize these equations, but you do need to be familiar with them enough so that you know what the letters mean and you know how and when they may be used. Okay, so the first one here, notice what that says, and I'm gonna say these like I want to say them, and I want you to say them. So I'm not going to say Vx equals Vxo. I'd rather you say, and I'm going to try and say, velocity in the x direction, or final velocity in the x direction, equals the initial velocity in the x direction plus the acceleration times time. Okay, and actually there is a little error here that I'm just going to correct here on the fly. This should be a lowercase x right there, or a subscript x, I should say. Okay, the next one. This one's long, but let's just break it down. What does this say? This says that the final position of an object equals the initial position plus the initial velocity times time plus 1/2 the acceleration times time squared. You'll use that equation a fair amount. The next one says that the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the change in position. Okay. And again, this x should actually be a subscript. And finally, this final equation is interesting. I find it very useful. The IB physics data booklet, which if you take the second year course, you'll get, has it in there. The AP physics equation sheet does not have it in there, but I'm going to give it to you now because I think it's a useful tool to have in your toolbox. It may be something if you go on to take the AP test that you'd have to memorize separately. But this basically says that the change in position equals the initial velocity plus the final velocity in parentheses divided by 2 times the change in time. So again, I want you to practice talking about these equations in full sentences, full phrases, not just saying the abbreviations. This will help you a lot in the long term. There are 3 really important notes about the equations that I just showed. One is those equations can only be used if the acceleration is constant for that portion of the problem that you're analyzing. I'm going to underline this because this is really key. If somehow the acceleration is changing for an object, then you can't use those equations. For the time period that you are analyzing an object's motion using those equations, that acceleration has to be constant. I will tell you, you're going to get some problems where an object moves at a certain acceleration, and then something changes, and later on the problem speeds up or slows down and reaches a new constant acceleration. And when that's the case, the third bullet applies, which is basically split up the problem into parts and analyze each part on its own using the equations just for that part that you need to, and then using different numbers in those same equations in the separate parts. All right, now let's talk about a problem-solving method that has really helped physics students over the years. Helps them organize, helps them understand. I will tell you at first, sometimes students say, oh, this seems like so much more work, but it really isn't all that much more work, and it is so useful to help you organize and stay thoughtful in your problem-solving approach. It has an acronym called DGUESS. You see there on the left, and the D stands for drawing. The G stands for givens, the U stands for unknowns, equations, solve, substitute. Okay, so let's talk through this. The general meaning for drawing basically just means make a well-labeled sketch of the situation. Now, sometimes students get really worried about this. They're saying a drawing, why do I need to make a drawing? It's really important just for you to just make a quick sketch. I usually do stick figures, less than 30 seconds. You set up a coordinate system, which we've talked about already. Coordinate systems are really important from this point forward. Define one direction as positive, the other as negative, and just draw stick figures or box cars, whatever the case may be. In the givens, you list your givens, and I'm going to show you a table that is really helpful to do that. I call it a delta X VOVAT table, okay? VOVAT for like the symbols, initial velocity, final velocity, acceleration time. I find that really useful. Again, students have found it really useful, and you'll see examples of that in the other video. Unknowns, indicate your unknowns. And basically in that table that you create or that's given to you, you're just going to put a question mark in the appropriate spot of the table. Once you've done that, once you've done the drawing, the givens, the unknowns, figure out which equation it works best for you to get to the next part of the problem, and write down the equation without substituting numbers. And basically what you want to do is you want to look over those motion equations that we just talked about and pick one where you know all but one of the values. And we'll get some practice doing that. Solve for the unknown. So algebraically, don't substitute numbers in, but solve using the letters for the unknown. All right, keep it in letter format until the last step. Sometimes students just want to plug in numbers right away. I want to tell you, it's more powerful if you stick with the letters. Sometimes nice things happen things cancel out and the equation becomes much simpler. And then finally, once you've solved for the unknown, plug in the numbers and calculate. And don't forget your units. That's really important. And I will take points off on a quiz or an assessment. If you write the right answer, but you don't properly label it with proper units, you will lose a little bit of the credit for that question. Okay, that's basically it for this video. You may want to go immediately to the next video, which I believe, which basically is has you walk through. I walk through 2 sample problems applying this DGUESS problem-solving approach. Thank you for sharing, and I appreciate your attention. Take care.